Well, hey there, folks. Welcome back to the Speaker Builder channel. My name is Jeff, and today I want to provide the third in my series on building a high-fidelity reproduction system. And today we're going to talk all about crossovers. If you haven't seen the first two parts, please check those out. In part 2, I talked about driver selection issues, and we left off with a three-way system being my preference for the sake of the best, I think, bang for the buck: single tweeter, single mid-range driver, single bass driver. Today I might do two 10s instead of a single 12, but in any case, whatever your preference is there, we need to talk about how to get these drivers to work together now that we've selected them. And again, of course, these drivers are just here as props, although this would probably be a nice sounding system, but they're just as examples is all they're here for. So if we're going to put these three drivers together, we want to talk about what problems would be introduced by just hooking the three together that will lead us to the necessity for introducing a crossover into the circuit somewhere. So let's talk about that. If we hook these three together, of course, one issue, we're going to have the impedance of the three drivers, if they're in parallel, reduced down to a very low level, which would probably not work out too well. But that's not going to be really relevant for us today. So let's move on to my number one. The first problem we're going to see, the tweeter is designed with its size, magnet, and so forth for just a limited amount of power. If you look at the size of the magnet going up from tweeter to mid and then to bass driver, the magnet gets increasingly large, the voice coil is increasingly large. It's designed to handle more power. That's because comparatively to the other drivers, the bass driver just has a much bigger cone, has to move a lot further, and so it requires more power to do that. Simple. If you have a bigger device, you're going to need more power to move it. So the tweeter, to produce the same volume level as the bass, just doesn't need near as much power. So the first problem we run into if we hook all three drivers together is we're going to be sending the full frequency range to this tweeter, and you more easily burn this out with no filtering. And then the same thing with the mid compared to the bass. If you subject this mid-range driver to the full frequency response, you'll more easily burn this out. You'd be very limited as to the volume level of that system. So we want to do filtering for that reason. That's number one. Number two, assuming all drivers have the same sensitivity level, when we have two drivers with shared frequencies, we're going to have a boost in the response in that range. Now, the problem here is that not all drivers have just this very, very narrow, limited frequency response. This driver, for example, will probably do flat to about 1,000 cycles. So if it's starts out at, say, in its nominal vented box, about 30 cycles flat, and then it's flat all the way to 1,000 cycles, well, by then the mid-range driver comes into play. And so, say that mid-range driver in a sealed box will, say, be flat above 100 cycles. So between 30 and 100, it's at the volume levels at one nominal level, and then now the two drivers are producing sound. And then that range between 100 and 1,000 cycles, you've got a higher gain or a higher output of your speaker system. And then it will drop again. Then the tweeter comes into play about, say, 1,500, 2,000 cycles. Now the mid-range and the tweeter will work together between that 1,500, 2,000 and about 5,000. And then the mid-range will drop out and you'll have just a tweeter. So you would have a response curve that's at whatever nominal level, rise up through 1,000, drop down, rise up again through 5,000, drop again. So it would be very, very uneven response curve. So that's a problem, number two. Number three, when you have shared regions of frequencies, as we've talked about, especially up here at this range, you're going to have what's called comb filtering. There's no way of avoiding, if your tweeter is at ear height, your center cone of the source of the waves for the mid-range driver is going to be at a greater distance to your ear relative to the tweeter. See, that distance is going to be greater, right? And so, especially the tweeters up here mounted on their panel, we're down looking sideways if you're up here, right, with your ear listening, ear at this height. Those differences in distances is going to cause problems when both drivers are producing the same frequencies, and you're going to get what they call comb filtering, or peaks and nulls in the response in that region of shared frequencies. And you don't want that. So you want actually each driver to reproduce just the frequencies it is targeted for and nothing else. And so we really want this base driver to produce just to 100, this one, or 150, this one just to that range up to, say, 2,000 or 3,000, and then the tweeter just from 2,000 or 3,000 up. Number 4, if these drivers, well, we were assuming before the drivers had all the same sensitivity level. That's not going to be the case. You're going to choose drivers for a multitude of other reasons, and it's not going to be so much a concern about their sensitivity level. Now, sensitivity is measured when you put a driver on a panel, on a what they call a baffle, to keep the back waves, in this case you don't have back wave, but to keep the back waves from interfering with the front waves. And you measure that, you put 1 watt in and measure it 1 meter out with a calibrated measurement microphone, and you'll get a certain response that'll be 90 or 89 or 91 dB or something like that. So those sensitivity measurements tell you how the driver is going to respond, at what level it's going to be responding at. Now that's not, when you put it into a passive design, obviously you're changing that, but let's assume starting without a passive crossover, the problem would be you're going to have different sensitivity levels here. And so that will change the response curve. So if this one is a little bit louder than the others, you're going to have to deal with that. So you've got that problem. You've got to adjust the sensitivity level of each of the drivers in your filter network system. And 1/5 problem I will mention here briefly is that in the base driver, for example, it may extend up to 1,000 cycles, but it may not be flat in that region. It may have a peak or a low point or something. It may misbehave above a certain target frequency. Again, the mid-range drivers will commonly get up into 3,000, 4,000 of this size, and they may misbehave, have peaks and nulls as the response rises. And that would be a problem. You want to not introduce that into your speaker system response. So for all of those 5 reasons, we want to filter these drivers out so that each driver, again, is just reproducing its target range. Just highs for the tweeter, just the mids for the mid-range driver, just the lows. So the solution to that problem is to introduce a filter network into this speaker system. And the filter network is going to include, I have a couple of sample capacitors. These are very small, is all I have around. Commonly, I think the crossover capacitors may be larger than this, but just for example, and these are probably electrolytic anyway, but so if you put a capacitor in series with this tweeter, and it operates as a high-pass filter, meaning that it filters out all the lows and the mids, and it passes only the highs, hence the name high-pass. Likewise, coils are used. These are actual crossover coils. Coils will be used in series with the base driver, and those will effectively filter out all the highs and the mids and pass only the lows, hence the name low-pass filter. Now that's a very simple explanation for filter networks in the passive design. Now the alternative to a passive design is to provide an active crossover design. And now the difference between passive and active, they call this passive because when you put components like this in the system, they are going to absorb some of the energy you're feeding to your speaker system. And they dissipate that energy as heat. Of course, you won't feel them get warm, but there will be a very, very slight temperature rise, measurable with very, very sensitive equipment, for example. But nonetheless, there'll be some energy loss. Now, in the passive design, we don't have to do any makeup gain for that energy loss because we're post-amplifier, and the amplifiers have plenty of power to compensate for any loss introduced by these passive crossover parts. So no problem there. In an active design, we're in the high impedance, low voltage end of the equation where we're a preamplifier, and we're going to intervene there post-preamp before we get to amplifier stage, and hence there is going to be signal loss that will be very significant. And so for that reason, there is a need to do makeup gain because your filter is still going to produce loss in a passive way. So we add to that circuit gain in the form of amplification, op amps, in my case in the electronic crossovers I'm using, and they provide makeup gain for that loss introduced by the filter. So no need here in the passive end, but essential in an active design because of where we're intervening in the signal path. So let me go over the two designs then, a passive system versus an active system. And then we're going to get into the fun part of looking at benefits versus drawbacks of these two designs. So a passive design would involve a signal source, say a CD player. Your signal then is sent to the preamp and then on straight to the amplifier. You might have an integrated component with both preamp and amp in one component, but we're thinking of them as separate parts of the system, and then on from the amplifier through its speaker wires to your speaker, in which it comes into the speaker box and then is sent through your crossover network of whatever design and then on to the drivers. And so the filtering is happening inside the speaker box. Now, in comparison to that, an active design, starting with your preamp, sending your signal starting with your CD player and sending that signal into the preamp, and now out of the preamp we're going to intervene there at the low voltage, high impedance end of the equation, and we're going to send that signal into an electronic crossover, which includes filter networks, much like these, and makeup gain stages that are going to make up for the loss in that electronic crossover. And then out from there, we're going to send now three signals, in a case of a three-way design, a high pass, a band pass, or I call it a mid pass, and a low pass, to three different amplifiers. And each amplifier will then drive independently just the tweeters, or just the mid-range drivers, or just the bass drivers. So now let's talk about a comparison of these two designs and how what benefits the passive system has versus the active system. And we're going to find that with every benefit that a passive system has, there's a consequent drawback with the active design. And likewise, every drawback that the passive system has, you get a comparable benefit with the active design. And so they really are opposite in that regard. Now, one thing I want to mention briefly before we go on, and that is there are speakers that are called active speakers, and they are generally built for studio monitors. And I don't hear of any hi-fi enthusiast using active speakers. Now, what an active speaker is, it is active in every regard as I've just described, except that the signal from your preamp now will go into the speaker, and then the electronic crossover happens internal inside the box, and then the amplification happens inside the box. So all of that work of designing and setting up the active system has been done for you inside the speaker box. They're often small monitor speakers like these. They're used for studio monitors. If you go to the big supply houses like Sweetwater, for example, or a number of supply houses that supply components for the recording studio industry, and you'll see their studio monitors much like this one, about the size of this one, and they are intended to be used as studio monitors. I had a reviewer claiming that the studio monitors, being active, were the best possible speakers ever, but you go to the hi-fi world and you don't hear anybody using active speakers for their hi-fi system. And now today, if you go to the recording industry and you ask the studio engineers, you'll find they're all using mostly active speakers with all the electronics, again, inside the box. Some of the PA speakers, high-end PA speakers with active design, the amps and so forth are mounted on the back of the box. But I just want to mention that when I'm talking about active systems, I do not mean active speakers like what we see rather in studio monitors. I'm talking about a system like we saw in the introduction to my video, in which we have all those components, the electronic crossover and the amplifiers, are all external. And of course, the reason for that is not only you can get at them, manipulate them, move them around, try different ones, but also the much higher quality. And we're going to get into that as we talk further about the two different system designs, and the benefits and drawbacks. Okay, now on to the most fun part of this video, and something I probably should do a separate video on exclusively just to talk about this issue, and that is the idea of passive speakers, what they actually are. And that really lines us right up to the benefits of passive speakers. The first one, number one here on my list, is simplicity of use and setup. If you buy any passive speakers, you bring them home, anybody can set those up. They're designed to be easy to set up. And on the back of the speaker, there'll often be what they call a cup with a couple of connectors on there, and one will be red and one will be black, and you hook the red up to the red wire up to the red end, black wire to the black end. Actually, you could get them reversed. As long as you reverse them on both speakers, both speakers will be in phase. It's only a phase issue. I don't know why they never made, like with power plugs, you can't reverse them. You have to put them in one way. I don't know why they didn't design speaker connectors to do that, so you could only plug them in one way, and then you couldn't even get their phasing reversed. But in any case, you could reverse the phasing and get it out of phase, and that would be a problem. So you just got to hook up the red to the red, black to the black. They're very simple, right? So that's the whole idea of a passive speaker, is this simplicity. They're designed this way. The reason for that, and that's a whole other discussion I just want to touch on, that is that passive speakers are basically a consumer-based product. They are designed for the wide variety of consumers, be it those who are technically suave and those who don't know anything about this stuff, and everybody in between. And so any of those folks can buy passive speakers, hook them up at home. So that's why they're designed the way they're designed. Now, there's benefits to that, and again, we're going to be talking about the drawbacks to that type of design. And we need to understand this so that we accept, okay, I like passive speakers, Jeff, so I'm accepting all these benefits and all these drawbacks. And I would respond to you, well, I don't like passive speakers, and this is why. Because the drawbacks don't outweigh the benefits, in my humble opinion. So let's get into this. Again, we're not talking about, as I said, active speakers. We're talking about an active speaker system that's self-built, in which all of the electronic components are external, not inside the speaker box, for real good reasons, because you can't jam all the stuff that I'm talking about. If you saw the intro here for this series, you saw my new system that we're listening to now. It's in the other room. The amount of stuff involved, you couldn't possibly fit inside a box. Big power supplies we need, the quality of the electronic crossover. It all requires a lot of space. You can't possibly jam that inside a speaker box. No need to anyway. Okay. So first benefit, we already talked about, simplicity of setup. Conversely, with an active design, much more complicated to set up. When I first built my first one, it took me 2 weeks to sort of wrap my head around how to get the system to work and get it adjusted right so that I was pleased with it. It was a real new experience for me. Number two, related to that, versatility and interchangeability. That's the whole point of a passive speaker, is that if you have whatever reproduction system you have, you can go out there and buy any passive speaker out there and bring it home and plug it into your system. Likewise, no matter what speaker you have, passive speaker now, you can go get any electronic equipment stuff you want and plug it in and make those speakers work. So that interchangeability is the whole point of the market, and why the market has thrived and why we have all these great products and speakers out there, because of that interchangeability. Without that, it'd be the same thing if when people develop systems, like when they came up with the Beta versus VHS, I'm really dating myself, I know, but you had to have universality in order for products to be interchangeable. So, and that allows the market to thrive. If you have 5 or 10 different formats for DVD back then, and you wouldn't be able to. The market can't thrive as well. So there has to be kind of an agreement, and so that's the agreement that the market sort of determined, that we're going to have passive speakers and that everything's going to be interchangeable. And so a great benefit to that for the general market. Now, number three, because of all that, my number 3 point is there's wide market availability with passive speakers. There's lots and lots and lots of options out there. Whereas with the active system, there's no market at all. I was told by a viewer there is one company, he told me this some years ago, who was building an active system, but it was all proprietary. As if I were to ever build something to sell to the general public, it would be all proprietary, so that it would have a certain sound to it, that when you buy this entire system, the electronic crossover, all the amplifiers, all the speaker wire, all the drivers, all the boxes, you buy the whole thing. And nobody wants to do that. They want to build their own, right? So I don't think there's any market. So you don't see active systems, at least bits and pieces. I don't mean an active speaker like I talked about, but speakers with nothing inside the box but the 2 drivers, and you got 2 sets of wires outside of a satellite box, and you hook it up to your own amps and your own tri-amp system or bi-amp system. Just not out there. No market out there. I mentioned in number 2, I forgot to mention with the active design, there's the active speakers that I have are unique. I can't take those speakers and hook them up to my friend's system because I don't have any passive crossover inside it. So it won't work. So I just can't. There's no versatility. Okay, and number 4, high quality factory built boxes. I'm so jealous of the boxes that I find when I get a real high quality factory speaker like the Vienna acoustic speakers that I took apart for a friend and rebuilt and did a video on. And boy, the quality of those boxes is just phenomenal. And I can't build stuff like that. But now there's a company, I'm told by my friend, who and I looked them up, and they will build boxes for you. So you can do that. I bought these from Parts Express. They're really nice, and I want to do something with these at some point. And so I can't buy big boxes for big vented bass systems anywhere, but there are companies that will make boxes. I build them all my own, as you probably have seen in my 5-sided boxes. I've done videos on that. So number 5, pre-selected drivers. Here, with the active design, you're having to pick the drivers. Why I went through the whole video last time on driver selection issues, because it's just presumed with an active system you're going to select your own drivers and you're going to deal with all those issues. The fact that the factory passive speakers, all that work is done. Drivers are all selected for you. You got to select your own. Number 6, pre-selected crossover points and slopes. What should the crossover point be between these and between these? All pre-done, all done for you. And with an active system, you've got to select those points, and you've got to figure out the slopes, and you've got to figure all that out. Number 7, pre-designed bass alignment with factory speakers. Whereas with active, you're buying a bass driver, and you're putting it in a box, and you've got to figure out, am I going to do sealed or vented or passive radiator or what a transmission line or whatever other alignment we're going to do, because we're building our own. So that's a bunch more work. Number 8, the driver output is pre-balanced. I mentioned that before. The sensitivity levels are going to vary, and also with passive design, you're impeding with each of the drivers as you hook it up into a crossover network. You're impeding the output of each of the drivers at different levels, and so you're not going to get an even response, and you're going to have to balance that out with Zorbal networks, which are a resistor to ground and a resistor in series, and you can attenuate one or more of the drivers to balance them out so they all have the same output, so your full response is nice and flat. That's all done for you, and you have to do that with an active system. In fact, with my active designs, I have to have some kind of measuring device. I use an RTA because I bought it for live sound stuff, live sound work that I've done, real-time analyzer, what that means, and I use that to just get me in the ballpark, and then sometimes I'll tweak a little bit, turn the highs down a little if those TC120s are a little bright, turn the bass up a little if I want a little more oomph. But I'm only talking one notch, one or 2 dBs of adjustment. But pretty much I need to start with flat response. And my RTA gets me there. So you have to have some kind of measuring device if with an active design. Number 9, 1 amplifier is needed for a passive speaker. And that's a big benefit. And everybody gets really up about their amp, their special amp. I'm no different. I have my special amp, my MOSFET amps I built from Marchand's stuff. Fabulous. So everybody has their favorite amp. You only need one. With a tri-amp system, hence the name, 3 amplifiers are needed. A separate amplifier, stereo amplifier for each pair of drivers, right? 2 tweeters, 2 mids, 2 bass for stereo operation. And then number 10, no additional component. So it's a little simpler. The active design needs an electronic crossover. That's a whole separate component, again, being external. So it sounds like the passive is the way to go. Well, certainly there's been a big, huge market in passive speakers. Are there any drawbacks to the passive speakers? There are a multitude of drawbacks. Let's start with number 1. There's a fixed sound character with a passive speaker that you're wedded to. That's it. So, and I look at some of the speakers. I was looking at the B&Ws. They have like a teardrop tweeter on the top of the box, and then they have a single mid and then 2 bass drivers in it. They look nice. They probably sound good. But that's whatever that sound is whatever that sound is, you're stuck with it. Whereas with an active design, because you've really sort of developed it completely from scratch, then everything is variable. You can decide one day, I don't really like these tweeters anymore. I can just swap them out. You can't do that in the passive design. That tweeter, if it's a 3-way passive speaker, that tweeter has been sort of wired in with various crossover components, and it's a fixed system. And so brings me to number 2. There's no driver replacement. Now, I say that. I have a passive speakers upstairs that I use in my TV now. They were my original high-end speakers, the passive satellite speakers from Focal kit or Focal design from back in 1990. And the tweeters burned out, and so I replaced the tweeters with some TC90s because they fit, and then nothing else would fit in there. But that's not going to be flat anymore. Who knows? You're throwing the whole thing off, so it's not really high fidelity any longer. I use it for the TV. They sound great for the TV. So if you have a passive design, you want to replace a driver, you're not going to find a driver that's going to, especially if it's an old speaker system, that's going to perfectly match the driver you had in there for sensitivity level, for impedance, for response curve, for crossover point. All that stuff's variable, and your system has to be designed as a passive design from scratch, and then it's fixed. So you can't just replace speakers if you want. Number 3, the low quality drivers. This is notorious, and I should probably spend a little time on this. There's no way around this. Speakers are the most expensive component by far compared to any other electronic component out there. And so it just requires to do high quality speakers at the level of quality that the amps are on the CD player and all are. I mean, I just compared a new CD player to my old $600 player, a 17 years old. The old one sounds great. So electronics are not that hard to do, but speakers are just so much more expensive, so much harder to do, because it's where the rubber meets the road. You're having to make waves on the air, and it's just much tougher to do in high quality. And so there's so much versatility and so much variability in how to do that. But it's just a very expensive proposition. And so speaker manufacturers, to sell speakers, they can't just be putting out there $3,000, $4,000, $5,000 speakers for people who have a couple $1,000 in electronics. People just don't have the money for it. They're not willing to spend it. So the market kind of dictates a lower price range, and that means that the manufacturer has to do something to lower the cost, and they lower the cost commonly with these problems that I've seen. The drivers tend to be lower quality compared to the quality of these drivers are far superior to anything I've ever seen, and these were kind of cheap, as I mentioned before. These are only $30. These Peerless, so and they sound good, but I mean, I'm talking $150 a piece for drivers that I would spend, that I want to put in this box, the Etons that I showed last time, and I want to buy Eton mid-range drivers. That's $150 a piece. So you're not going to find drivers costing $150 a piece in a speaker system costing $1,000, $2,000. You're just not going to find it, because you just can't make a profit doing that. It's too much money. The profit margins are huge in speakers, and go listen to Danny Ritchie about this. He's talked about this in his channel, GR Research. I watch his stuff. He's you want to really know what's going on with passive crossovers, go watch his channel. He's building those every day. He makes a living at it, so he's a pro. And he talks about the very high cost of doing speakers, and the profit margin that's necessary requires, cutting the price down somehow, and it's cut by the quality of the driver and the quality of the crossover parts. And he tears these speakers apart that folks send him, and looks at the crossover parts and is scratching his head saying, this is crap. Well, he doesn't say it that way. He's more kind, but that's the basic bottom line. So the quality of the drivers and the quality of the crossover parts commonly are sacrificed to get down to a certain price point so that you can afford the speaker. And that's been something has troubled me, and I've been railing against my whole life of dealing with speakers. So number 4 then, and this is very important to understand, and this is a little bit different, irrespective of quality, and I'm convinced no matter how good the quality of the crossover part is, and Danny is arguing that he can build a crossover that's virtually invisible, and I would like to take him to task on it with these boxes and the Eton drivers and send them to him, at least to send the front panel to him, have him build a crossover for it, see how good it would perform. I'm tempted to do that, but I don't think. I've asked one viewer just recently on some of my new videos, and he says, no, you're still going to get lost. I think there's going to be always a loss at the passive end in both clarity and dynamics of your speaker system. Now, I talked about energy being absorbed by these, and there's no problem. There's plenty of makeup gain available in an amplifier. So amplifier can drive a speaker with all the crossover parts in it you want, and it won't. You'll always have plenty of power to drive it. That's not what's at issue here. What I'm talking about is the loss of clarity when a signal goes through a capacitor. And again, this is a sample, but they're generally origin in this electrolytics, or rather, I'm sorry, the polypropylene caps that are, well, they do use electrolytics, but they're crap. But polypropylenes, for example, that I've used in passive crossovers I built, you're going to get loss of clarity, not just loss of energy of signal, but loss of clarity when the signal travels through these components. And there, I'm just showing two, a coil and a capacitor as samples, but there's often 2 or 3 capacitors, several coils, and then some resistors, and so you've got all these parts, and they are absorbing energy and absorbing clarity. What Danny Ritchie's doing is he's replacing those parts with much higher quality ones, but I don't think you can entirely, and that's the key issue for me I'm wrestling with, I don't think you can entirely eliminate the loss of clarity, number 1, and on my list here is number 4, diminished clarity for the passive design, and second of all, number 5 on my list, the loss of dynamics. Now, let me explain that briefly. With dynamics, you have, say, for example, a bright signal, a crash of a cymbal, a pluck of a bass or something, and it's a very momentary loud, soft. These momentary these momentary peaks in the sound, and that's what makes music so interesting, is those dynamics. So that high energy pulse comes through your system, hits your passive crossover components, and is dampened. And then by the time it gets to the driver, instead of being a bang, it's kind of a boom. And I'm not exaggerating. It's really significant. When you eliminate these parts in your active design, it's really remarkable how much improved dynamics you hear. And it took me a couple of months of listening to my first Triumph system I built in 05 to really begin to learn and hear and appreciate that. Wow, your system is just so much more dynamic. Now I pay attention to it. And I say, oh yeah, listen to those dynamics. Compared to a passive design, you're absorbing energy with these, and you're going to absorb those peaks, and you're going to have less dynamics in the speaker system. There's no way to avoid that, I don't think. Even if you can put such high quality parts in there to make it really clean, as Danny's arguing he can do, I think you're still going to have loss of dynamics. There's no way to avoid it. No such with active designs, no such loss of native clarity, no such loss of dynamics. So you're gaining all of that. Now, I'm going to make this point, and then we'll go on to 6, 7, and 8. There is an argument can be made that having done recorded music for 10 years for folks, and I never was a professional at it, but I did it right here in this room, about in the same position as this room that I was in back then, with the table I had it set up, and I had this whole room opened up and was recording bands. Great fun, loved it, very, very, very hard to do. But one of the things that I learned, the point I want to make here is when you realize, and I've been in the studio with bands a couple of times, 3 times, and they're all using, back in the day, up through till recently in the last 10 years or so, passive speakers to doing mixing and mastering of the recorded music. And so you're listening to music on LP or CD, whatever, that has been, for the most part, mixed and mastered using passive speakers. And so they adjust the EQ and they adjust the dynamics and all of that stuff, assuming you're going to listen to this, the playback system is going to be in a passive design. And now I come along with an active design, and I'm getting much more dynamics and much more clarity and brilliance than was even intended by the engineers who made the music in the first place. And so, is it appropriate to have active systems then? Well, that's the nice thing about speakers. There's no rules here. You can do whatever you want. So it's all a matter of your ears. Does it sound good? That's all that matters. And to me, the active systems, and I'm using bright tweeters, there's hard dome, metal dome tweeters. My focals are much brighter than these, and you can overdo it. I've got some Audax right over there, some Audax tweeters that are just ridiculously bright, or the TC90s that I bought for my old speakers. They are ridiculously bright in active design. They're unusable. So you can overdo it. But so it's a matter of just got to adjust for your ears, what your ears like. And again, that's one of the benefits. You can do whatever. You can set it up any way you want. You can buy tweeters, listen to them, set them in there, listen to them for a week, and you don't like them, send them back and buy different ones. So, and I've done that. So, but anyway, so there's some argument can be made that active systems with this increased clarity and dynamics was never intended in the first place. You could make that argument. I understand that, so I have to think in those terms when I'm listening to my music, that if it sounds a little bright, well, it was mixed on a passive speaker probably, and it wasn't going to be this bright. It wasn't this bright when the engineer finished, and the mastering engineer finished with the product. It wasn't probably all that bright. But I'm getting reproduction that sounds like the instruments in the room. And if you ever listen to live bands close up, and you're on the first, second row in a club, it's bright. The cymbals are bright, the guitar is bright, the horn is bright. I mean, stuff is really bright and loud. Well, that's what live sound is, and that's kind of doing bands for many years is kind of what I'm after. So that's my preference. Anyway, on to number 6, second order filter. Now, with passive designs, because of this loss of clarity and loss of dynamics, the passive design is limited to how many components you put into the circuit for filtering. So if you put one filter in here, one layer of filtering, one capacitor across the tweeter, one coil across the bass driver, you get 6 decibel per octave filtering. So suppose, for example, you want to filter the bass driver at 100 cycles. So 100 cycles up, you get 6 dB per octave. So you put one coil in there and have the certain millihenry value, and so it has a 6 decibel per octave at 100 cycles. So up at 200 cycles, it's attenuated by 6 decibels. It's not very much. And then at 400 cycles, it's attenuated at 12 decibels. That's not very much. So usually first order is considered insufficient for passive crossover design. So they usually go to second order, and the second order involves another in a two-way design. Theoretically, it's a single coil across a bass mid driver and a single capacitor across the tweeter. And then if you want to do second order, you add another coil and another capacitor in the circuit, and you get second order, 12 dB per octave. But now, as you imagine, continuing to increase that, go to third order and fourth order, and you got now 4 coils for a two-way design. Say 4 coils and 4 capacitors. That's theoretically. The actual design may vary from that, but you're getting a fourth order network now. Very nice sharp slopes, say for the between tweeter and mid, say at 3,000 cycles, which might be what I would cross these at, or 25 or something. You got a nice sharp 24 dB per octave slope either side of these drivers, of this crossover point. And so that's great. But now you have so many components in the passive design in that circuit. Not a problem for plenty of amplifier power to overcome loss of signal strength to the drivers, but that's not the problem. It's loss of clarity and loss of dynamics. That once you get past second order, you start to really hamper your speaker system and really dampen it down to a point where it's unacceptable. So generally speaking, you'll see second order. Third order and fourth order are far superior, but because of that problem of introducing too many crossover components, both the additional loss of clarity and additional loss of dynamics, plus the additional expense, these coils are real ones, the good ones that I've used, they can be $25-$30 a piece. And so you get 3 or 4 of those in a circuit, and that's a two-way. And you got more for that for a three-way. You're pushing a lot of money. And again, the cost here is just extraordinary for a passive speaker, and they're having to cut costs to make a speaker hit a certain price point to make any money. Nobody's going to take the same system somebody else is selling for $1,000, and because you went crazy and put high quality drivers and and you're selling for $3,000-$4,000, nobody's going to buy that. I mean, it's a real tough market. Speaker building is a tough market, a lot of competition, and so there are hugely expensive speakers that are. My friend has the $7,000 Ariel 10Ts, and they're still passive, and I still argue with him about that. I still think they don't have the clarity that anything close to what I can achieve with an active system. But still, $7,000. They're built. They're very well designed, but passive crossovers are just killing those speakers. They're just sucking the life out of them, in my humble opinion. And I'm being too harsh, perhaps, because this is a benefit versus drawback. And so this is what I'm really trying to say here, is that if you accept all these drawbacks, and accept and get the benefits of it, then passive is the way to go. I'm not accepting these kind of drawbacks that I'm talking about here, and so I'm looking for active design. Number 7, 1 amp operates the full frequency range. And that's generally not really a huge problem, but you think about especially a 3-way design with all the crossover parts involved, that's a hugely complex load for that amplifier. Well, that's actually number 8. Number 7, well, I think what I'm talking about here is you're having a driver having to produce the low frequencies at the same time as the high frequencies or the mid frequencies. And the amplifier's power supply, when a heavy bass, this is a special one example of a problem, when a heavy bass signal comes through and the amplifier has to produce a heavy bass signal, it's taking all power from the power supply to do that and robbing the power supply of the power needed to manage the dynamics of the mids and the highs. And so one amplifier in a system is just, it's taxing. And one of the solutions to that is to have a passive 2-way and then an active crossover here. That's the system I built in 1990, and had a separate amp to drive in the basses, or you have today subs that have their own amp, and you have that handling the low frequencies. Then you just have a tower or a satellite speaker or whatever that has just the mids and the highs. So that's a workaround. And number 8, I started to talk about impedance load. Very complex impedance load here, with whether a 2 or 3-way, with all these passive crossover parts and the impedance of these drivers being subject to frequency, and so they vary with frequency, and you've got to, so it just presents to the amplifier, a passive speaker does, a very complex impedance load, whereas with an active design, you have an amp just driving a single voice coil of one of the drivers. And that's a far easier impedance load for the amplifier to manage, and so it's far better. Amplifier is just, it's got a smile on its face. It's just happy because it doesn't have this complex load to deal with. Now, I briefly mentioned this in my notes. I mentioned that the 3-way is more complex than the 2-way. The material that I was reading back in the 80s from Speaker Builder magazine, Audio Engineering Society publication that I was turned on to by my friend Joe, suggested that the 2-way is the limitation for them, that they avoid a 3-way passive design. And so because of the additional complexity of adding a third driver to this circuit, you're really sort of putting 2 voice coils and a bunch of passive parts into a single circuit and trying to get them to all work together well. It's very complicated to get those to work and to work well. And now you add a third driver to that mix and more crossover components, and you theoretically really mess up the farm. And so many folks have suggested stay with the 2-way passive, and that's why I built the system I did back in 1990, 91. I had a 2-way passive satellite speakers and an active electronic crossover here that's up the shelf there, sitting on the shelf up there. It's broken anyway. And electronic crossover here between bass driver and these satellite speakers. And then a separate amplifier that drove the bass speakers, and then one amplifier that drove the satellite speakers. So, and that was unusual at the time. Guy at the Hi-Fi shop said, Jeff, when I explained what I was doing, he said, nobody's doing that. But the stuff was available. This electronic crossover I got from audio, since I'm talking about it, the audio control Richter scale, it had electronic crossover in it for bass. And then it's got a bass EQ, half octave bass EQ, and it's even got a warble tone generator with a meter on it, and you can adjust it. And it's got a flat measurement microphone. It's really cool. 30 more years old and mostly broken. EQ still works, but the electronic crossover doesn't work anymore. Linkmans Riley's 24 dB per octave network in that. Anyway, so I want to close out with crossover points. So with between the tweeter and the mid-range amp, to select a crossover point here, the driver's frequency response is a limiting factor here. To get even a 5 1/4 driver like this to extend up to 5,000 is very, very tough. It extends up to 3, and then it may be dropping off at that point. It needs to be very, very gentle in its drop-off slope to work effectively as a passive. In the active, of course, it doesn't matter. You're going to shelve it very, very sharply, 24 dB or even 48 dB per octave. But in a passive design, you want You want to have a nice gentle drop-off slope for the mid-range driver without a lot of misbehavior up there at 4,000 or 5,000 cycles. So you're going to have to get off of this driver. You want to run it up to about 2,000, and then you're going to get off it. Now, the tweeter, you can't drop this tweeter down much below 2,000 cycles. Most tweeters, they have a resonant frequency of around 1,000 or maybe below 1,000. So you've got to be crossing it at about 2,000. And that's usually your lower limit for a tweeter crossover point. And so you can see right away that you're very, very constrained as to where that crossover point is going to be between a tweeter and a 5 1/4 mid-range driver. You're going to be at about 2,000 to 3,000. Above 3,000, you won't get any performance from your mid-range driver. Below 2,000, you're not getting anything from your tweeter. So you're in that narrow band, 2 to 3,000 for a crossover frequency. I'm commonly with a 5 1/4 driver that I can get good response up to 3, even 4,000 cycles. And why I choose a small mid-range driver is for that reason, so that I can get a nice extension up to 3, so that I can cross this tweeter at 3,000. I like to get it up there. I don't want to cross this tweeter down too low. It saves on the tweeter's life. If you try to overdrive the system occasionally, you make it really loud, the tweeter will survive a little better if it's crossed a little higher. Also, the tweeter won't tend to honk. Some tweeters will have a certain honking character when you cross them too low. And so crossover frequencies tend to be, I try to get them up high. 3,000 is about as high as you can usually cross a tweeter before your mid-range driver begins to misbehave. And so, but you're in the 2 to 3 range. I've seen tweeters crossed at 4. So the mid-range driver happened to be well behaved enough to get it up that high. But generally you're in that 2 to 3 range. And then for the lower crossover point, the common crossover frequency for a lot of subwoofers is 90 cycles. Why 90? Why not 100? Whatever. But you're in that 100 cycle range. You certainly have a lot more latitude here, because often these even 12-inch drivers may extend, as I mentioned, all the way up to 1,000 cycles. And this driver is going to come into play. Say you put it in a sealed design, and so you're at about 100 cycles before you get drop off below that. And so your lower limit is 100, but your upper limit isn't limited, of course, with mid-range. So you have a lot of latitude. You can cross this over 100, 200, 300, 400, 500, 600, 700, 800. But generally speaking, I like to keep it down low to 100, 150. I'll push the crossover frequency up to 150 cycles max, because I want the maximum amount of cone motion of waves, of those longer waves, limited to the base driver, and not subjecting the mid-range driver to those lower frequencies. So 100 is fine, 150, anywhere's there. I've heard of folks crossing at 200, 200 is fine. So you're in that range. Now you're going to change the character in that 100 to 200 range as you sort of shift off those frequencies to the bass driver instead of the mid-range driver. You change the character of the sound. And so one of the challenges that I have with electronic crossovers, I have fixed modules, crossover frequency modules that I can plug in, and I don't want to buy a whole bunch of those. So I pick a frequency 150, sort of a halfway between 100 and 200, and I plug it in, and I'm happy with it. But it'd be nice to have some of the active electronic crossovers made for the pro audio world. I mean to say, they have adjustable frequency, crossover frequency on them. And that's not really high end. Some folks have used them for their hi-fi system. You can buy those. You don't have to go to Phil Marshall or whatever. You can buy those through your supply houses that supply for pro audio, for pro sound is what I mean to say. Pro sound, which is, music reproduction for live bands and so forth. I've done a lot of that work. And so those have an adjustable crossover frequency. And so you can sit there and listening to whatever music and then adjust that frequency and adjust the crossover point around and listen to what it sounds like and pick the one that you like and then build your active design from that. But I've never had one of those and never had a chance to do that. And one other point about bass drivers, if you are only using one bass driver, then you really want to keep that crossover point way, way down low, because just one driver, you're going to have to place that in the room somewhere. As you get up into upper frequencies, you begin to get into stereo separation issues. And so I always use 2 bass drivers, so I never really concern myself with that. That's why I can cross it up higher. The base driver may be located not very far from the satellite speakers, so I can cross it higher up to 100, 150, 200, but if you only have one subwoofer, then you really want to keep that crossover point down really low. It means you're going to have to probably use perhaps larger mid-range drivers if you're going to design it that way. I designed that system, satellite subwoofer system, that way. It had 6.5 bass mid drivers, and so those can cross way down at 100 cycles, 90 cycles, whatever, and to have a single subwoofer in the room. So you want these to do more work. One other final consideration about crossovers is that if you want to build passive designs, and I'm thinking about doing that, I haven't looked into this too much, but I understand the REW software, the Room EQ Wizard is what that stands for. It's a free software available. A lot of folks are using it. You buy a measurement microphone and a 2-channel preamp, I'm told, or maybe somebody talked about using just a measurement mic that had a USB input and just no preamp. But the other research I've done on it suggested a 2-channel preamp to use with it, with a measurement mic. So it's a couple $100 and then a laptop and their free software. You can do all kind of speaker measurements with that. If you can get the full TS Thiel small parameters, I don't know, but that's what's needed. And then build your own passive crossover with the measurement capability that the REW offers you. So thinking about looking into that, but generally speaking, building passive crossovers requires not only a whole lot of parts, not just cheap junk like this, but you have to have a lot of parts, because you've got to be swapping out different values of coils, different values of capacitors. The capacitors aren't much money, but the coils certainly are a lot of money. And you need a bunch of different values on hand, and you got to swap them out until you find the one that you're going to use. And now you've got all those others that are spare that you're not going to do anything with. They're just going to sit and collect dust, and you spend a lot of money on them. And so you could buy cheap ones and get your crossover design right, and then buy the high quality ones, I suppose, for your final design. But it requires not only a lot of parts on hand, there's a lot of learning involved, a lot of experience. You need the proper test equipment. I mentioned spare parts, a lot of time and effort. And then there's a well-developed critical ear for hearing this stuff if the drivers are out of phase, or if there's peaks or nulls. The great measuring tools available can keep you out of trouble with regard to peaks and nulls. And I understand you can even measure comb filtering and things like that with the REW. But so that would be a great tool, and I'm thinking about doing that. I might have fun just building some passive speakers and fooling around with that as I look forward here. But back in the day, there was no such tool available, and it was just a huge undertaking to build passive crossovers. So if you're interested in doing that, I still think if you're only going to build 1 or 2 speaker systems, I can't see going to all the trouble to get all the parts and the test equipment and all that just to build a couple of speakers and then you're done. This is what Danny Ritchie is doing it all the time, every day. He's building passive speakers, developing the passive speaker crossover networks for his speakers for his clients. So I did turn to Matasound for my other projects, passive projects, to develop the passive crossover. It was theoretical. They would measure the drivers, which was good news, and so they would build these theoretical crossovers using the LEAP software for their drivers that they had measured and got all the Thiel small parameters directly from the drivers rather than relying on the manufacturer's specs. And that was much better, much more accurate. But nonetheless, it gets you in the ballpark. It gets you 90%, 95% of the way there. But you can't get that extra couple of percentage points without playing around with it and doing careful measurements yourself and all of that. So, and they are no longer doing that. They're the guy they had developing that. They would actually go into the software and do what you would do live, do in the real world. They just did it in software and let the software kick out what was a flat response. And then they send you the design and you buy the parts from them and you put it together. And I've done that, and it's successful for the most part, but it's not true high-end. Today, if you really want to do it, as I talked about with these boxes, send Danny the tweeters, one tweeter, one mid-range driver, maybe just the front panel or maybe the whole box if he needs the whole box, and let him build it. and that would be my option at this point. It's much more expensive, obviously. I don't think he's charging huge sums of money. He's talking hundreds of dollars, a couple, $200-300 for the design and the parts. And so, because he's rebuilding crossovers for other speakers. Great work he's doing. If you're interested in that, go check him out. Whereas with the active design, to the extent you have flat response of each of your drivers, you almost can't miss. You pick a proper, appropriate crossover point. You got flat response here, you get flat response here, and you get imbalance with your RTA. You got flat response in your system. It's really not hard at all. So much easier, and that's why I like doing active systems as well. I don't have to deal with all this paths trying to figure out how to build passive designs. I can do it myself and play around with parts and do all that. So. And finally, of course, as I mentioned, you have to have some means with doing active designs yourself to measure amplitude, to make amplitude measurements. I'm using the RTA. The REW software probably would allow you to do that. You would get, you do a sweep tone of the entire system to see that you're flat. And you get an impulse response, so you're not including in that measurement your reflections. You're getting just a direct sound, and in the time domain, the software allows you to cut off in terms of the time, the length of time that you're measuring. And so you're only getting the initial response, the impulse from the drivers, and all the reflections are eliminated from your measurement. And so you're only getting just a drive. That's fabulous, because otherwise you need an anechoic chamber to do this measurements, how it was done in the past. So now you can do that with the REW software. Pretty amazing. That's really a really cool and awesome benefit of that software. So that's all I have for today. Any questions or comments, please include those, and I'll respond to those. And otherwise, we're moving on next time to part 4. We're going to be talking all about boxes, and whether with tower or satellites or and base boxes and all of those issues. So we'll see you all next time.